This is a re-recording of a live technical webinar that was undertaken on the 16th of June 2023. Due to some technical issues, the recording failed, so this is a complete re-recording of that webinar for users. Welcome to the Model Builder 101 webinar, which today is going to be all about Model Builder and how you can incorporate it within your projects on civil site design. The aim of this particular session is to teach all users on all platforms the absolute fundamentals of Model Builder. So the first question I guess we can ask is, what is Model Builder? And essentially Model Builder allows designers to construct a model using a collection of strings and codes, and these can be any strings and any codes within your particular project. And the great thing about Model Builder is that it allows users to control the range or the extent of the line work and those strings within the actual model and have those dynamically update in the background. Now I'm going to be operating on version 24 today, and the interface got changed, was it December, at the end of last year, 2022, to basically make a cleaner and more user-friendly interface. One of the sort of main questions that I guess people typically ask is, well, I'm using Totalmodel, why do I need to use Model Builder? And Totalmodel is a model that automatically collects the road strings, your network strings, and as I've mentioned in the text there, curb returns, cul-de-sacs, knuckles, roundabout tool, etc., and connects them together. And it does a whole ton of trimming as well. And in fact, if we have a quick look down here, you can see that the curb returns, when they're implemented, the road gets trimmed back. And this model will continually build itself and be added to as we create more road strings and network strings. Once you begin to sort of design outside of that particular extent, outside of the road and outside the curb, which for in this example we're looking at parking bays, we need to begin to employ Model Builder to basically connect those other additional strings to the road design that we have here. One of the main questions we also get asked is, when should we use it? And there are typical scenarios where we would expect users to open up and start to use Model Builder as opposed to just simply operating with the Totalmodel or the Totalmodel. And as we've already said, simply using it to collect different strings together. So if you've got grading strings, profile strings, and obviously your road and network strings, the only way you're going to be able to join those together to create one coherent model or surface is using Model Builder. There are other scenarios though. Certainly when designing with a single cross-section template is, and I've put difficult or prohibitive. A good example of this could be, for example, where we have laybacks. We've got a barrier curb, then a layback, and at the moment this is all in one single cross section. So we're kind of limited to using design variations and maybe using match to profile string along those lines to set elevations of the design. Whereas with a Model Builder model, we could have this footpath designed completely separately and then have it connected back to the layback or the barrier curb as one single model, but actually having them designed independently of each other. We did a string code techniques webinar, which is available on our webinar channel or webinar playlist on our YouTube channel, which really unpacks that in more detail, how to design things separately and have them connected. And we're going to be touching on that today with the parking bays. Another good example is really when alignment geometry is not compatible with cross-section based design. And as you can see here, we have perpendicular line work to the road. And the problem with perpendicular line work is it's not suited to cross-section based design at all. The design of this road, if we were using variations, only makes changes wherever you have sample lines. So we would never get this really nice clean design of the edge of the parking bay here. It would never work. Same goes with what's going on down here. The software would have great difficulty in modeling if it was all in the same cross section. Strings are overlapping. Now this does happen very commonly with particularly on curb returns, where we end up with batters being applied or daylights being applied to the back of the road, and then we have daylight being applied to a curb return, and the software draws where it believes the batter should be, but obviously what ends up happening is all three of those potentially overlap. So we use Model Builder and simply use trimming of Model Builder, which we're going to explore today, to cut out the bits of code that you do not want to display. And in this case, with curb returns in particular, generally what people do is they'll actually remove the batter code entirely from the curb return, removing that little overlapping area and meaning that you can clean it up. And the last one is really to look at using the model builder surface that is generated to apply other strings onto it. Typically, again, things like car parks. You build a car park, you create the model builder surface, then you have a surface to drape the islands onto. And we're actually going to be looking at something sort of similar with regards to how islands can be placed in the road. Because this happens, and for many users they'll see a lot of this sort of what we call sort of sawtooth thing happening, or zigzagging of the model, and it can raise sort of concerns as to what's actually happening. And all that is happening is the fact that we have multiple strings or multiple codes overlapping each other. You have to remember that Model Builder takes all of your strings and connects them together and simply reads those strings to build a model. If there are strings such as this one here, which is the centerline of this road, ploughing straight through the middle of this island, the software is going to try and model that. Not only is it trying to model that, but it's also trying to model the curb of the island at exactly the same time, which is why we've got this happening. And we will make reference to this in the webinar, particularly when it comes to using strings to manage the elevations of codes, and how you can end up with something very similar happening. What about pasted surfaces? And I've seen pasted surfaces used a great deal by users. They've found that pasted surfaces are a great way of combining different surfaces together to create a combined sort of master surface at the end. Bear in mind, pasted surfaces combine surfaces only, and I said they're not strings. Surfaces are great, and Model Builder creates a surface which you can then combine with other surfaces. A good example of that is in our Getting Started series on our YouTube channel, is that we actually take a Model Builder surface, combine it with the natural surface to create a final development surface to build on or design on top of. So it's worth noting, yes, pasted surfaces are good, but you have to have a surface. Profile strings, for example, don't generate a surface. Okay, so you'd need to use Model Builder. The good thing about pasted surfaces is, though, that they are dynamic. So if your built model, which is using different strings, such as maybe the one we're doing today, if any of those receive any updates design-wise, your pasted surface can also be updated. So the whole entire thing can be dynamic from start to finish. So we're going to be using this particular project today. You can see there we've got a typical sort of road design going on with some curb returns being applied. This is a total model, or auto model. Now what we're going to be doing is applying 3 parking bays along the edge of the road to basically finalize the design using Model Builder. So first thing, we will have a look at the profile strings that we have pre-created for the purposes of the parking bays, so you guys can see how we've assigned the elevations to them, because there's a very, very good tool called Surface Extend which will basically help us assign the elevations and make sure we get this nice tie-in. Model Builder is not about setting elevations of strings and making sure you've got those tie-ins. It's about simply getting the geometry of your strings to fit together. We're going to create a new built model. We'll show you the differences between linked and not linked to Totalmodel. I have seen this confuse some users, so it's worth just unpacking how that works. We'll then add the profile strings or the parking bays to this particular model, looking at using some trimming and extra sections to remove the road design from the areas where we want the parking bays. We'll also add, and it's not in this image, but we will add a little island in there to show you what happens when we have overlapping mesh and line work between strings, to show you the result and how we resolve it. We'll have a quick look at how the line work in Model Builder works, because Model Builder works slightly differently to the sort of traditional auto model or fast draw line work that is drawn by Civil Site Design, and actually has separate layer controls for the fast draw line work, so we'll unpack that. We will create a quick subgrade model for the purposes of plotting cross sections. Also very briefly show you a tool which has been kicking around in the back end of the software for many years now, which will generate a quick profile view of your models. Doesn't have to be Model Builder model either. We'll unpack that, and then lastly we'll plot cross sections. We will actually plot a long section as well, but predominantly most people are going to want to see cross sections along the road showing the parking bays either side. And the great thing is, for the first time since the Subgrade Model Manager came out, we can now combine the cross section plotting showing the model and the subgrade underneath. So if you are using a version that is older than v23.1, the model builder options are found up here. We will also be looking at something called string code surface extend. So really everything you need is going to be found in here. For those of you that are using v23.1 onwards, and for the duration of this webinar, I'm going to be accessing all of the functionality via the tool space. So things like my strings that I've got for my parking bays, any models that I may have created such as surface extend models, which we will explore in a second, are all found in here and all accessible for viewing and editing straight from the tool space. So let's have a look at how the profile strings have been set up. So we've got some Civil 3D alignments. This is being designed on top of the Civil 3D platform, but as the first slide indicates, this is completely platform neutral, so there's nothing I'm doing in here which would restrict you on any of the platforms. You can do all of this. It's just the fact that you'll be using Civil Site Design alignments if you're using the AutoCAD, BricsCAD or Civil Site Design Plus platforms. So we've generated these alignments, and then on top of which we've then placed a profile string. Now there is benefit in using a profile string for parking bays such as this, and if we just have a quick look at the tool space here and hover over parking 1 and click on resample sections, the main benefit over using grading strings is that you have the option of different spacings and sampling. On a grading string, you have one value for spacings, and that is applied all the way along your string. And normally what that means is with a string such as this, your spacing value has to be applied to the lowest common denominator, which in this case would be the radius here, which means that we'd be putting in a value of 0.1. And that 0.1 value would maybe be applied along the entirety of that string for grading. If you've got a lot of grading strings in your project, having that kind of value applied to many of them can actually get very process hungry. This is why, and I've actually been quite a bit of a flag waver for grading strings in the past, but actually profile strings do have their benefits. You can still move them around by using the Civil 3D alignment or the Civil Site alignment in the background. You can still move them and then adjust them. We'll actually do that with the island a little bit later on. So they're still pretty flexible. The key difference is though that for the tangents on the string itself, we can put a larger value than that of the arcs, which means that we don't get lots and lots of computation happening at a very, very intense rate. 1 is a fair value, okay, and 0.1 for the arcs. So this is how they've been created. The template that's being applied, we'll just have a quick look at the template, is very simple. If we just hover using the hover function, you can see the little green tick. This indicates that it's being used. Unfortunately, the hover does disappear after a certain amount of time, so what we might do is just go back and actually see the template by right-clicking Edit Template. And this is the template. Very, very straightforward, just a simple barrier curb that's being applied around the edge. The same goes with the parking bay right. It's an identical one, it just happens to be on the opposite side. So let's have a look at the elevations. How are we going to tie this parking bay into the edge of bitumen of our road? Well, if we open up the vertical design of our parking bay string, parking 1, by right-clicking and opening the VGE, and then heading off to Auto Profile, you'll see that we have a little entry. I'm going to double-click on this entry. So we've used a reference surface, which is basically matched to surface, and we're matching to a surface called SE, which is surface extend, new road, left side extend. So let's see how that surface has been created and why that is giving us the tie-in that we're going to be needing, because you can see there's a lot of detail that's going on here. The extra sampling, 0.1, around these arc values you can see is being applied, but because we're putting in 1 meter spacing around the straights, it's a lot cleaner. You certainly wouldn't get this with a grading string if you were using 0.1 all the way around. Let's close this down. We have a function which, as I mentioned earlier, is called string code surface extend, which is in the ribbon found under the model builder pull down. But for users using the tool space, you can actually find it by right clicking on models and opening string surface extend models. We've created 3 models, and in actual fact I'm just going to do this very quickly. I'm actually going to display the mesh of one of these surfaces so you can actually see it in a bit more context. To do this, again, very, very simple. Right click, toggle display, and we can go show mesh on new road, left side extend. Now, for those of you that don't know this, if you expand surfaces, your surfaces are actually categorized into what type of surface they are. This is an extended. I could have done the same thing by right clicking here, show contours and triangles. There's multiple different ways you can actually access this functionality, which is quite neat. So what's happening? Let's have a look at the surface extend by actually right-clicking on the surface extend. It'll take you back to exactly the same form. This is a fantastic feature, and it actually, I would say, surpasses other features we've got, such as reference line found in Auto Profile. What is happening here is that we're creating a plane or a surface connected to the left side of the road on the LEB code over a chainage range of our choice. So it starts down here, finishes up here. Okay, pretty random. But what it allows me to do is to say, right, I'd like you to project the current code slope sitting there on the LEB, which is currently it's a one-way crossfall, so it's a positive 2%. I want you to project that slope for a continuous 6 meters out towards the left-hand side. This is live. So what happens is if I change my road design and this slope here changes, or even the LEB position changes, this model will update and continually update to reflect that. You also have the option in here of picking a value. So if you didn't want to have, for example, the slope of the road being projected, you could put value in here and put your own crossfall, positive or negative. So if you wanted it to be minus 2% or minus a value of your choice, you can pop that number in here and still have that same extension. The extension is simply to cover the extent of where my string is going to go. You've also got the option further down of code plus a value. So the code slope, 2% plus 1% would give us 3. Okay, so that's how that one works. I'm going to leave it as code, just put 0 in here. So what this means is that we get a really lovely tie-in to our string, because our profile string is matching onto this surface, and because this surface is being drawn exactly at the LEB code and drawn out, we get a perfect tie-in around both the start and the end. Okay, don't forget you can also have your auto profile entry matching on, just for example, and if we have a quick look, just at the start and at the end. This is a great little tool just to have maybe 2 little surface extends or 1, and just say matching for the first, I don't know, few hundred mil and the last few hundred mil. You can use this as a method of tying in a string back onto an existing feature or a design feature that you've got. You can also, with your auto profile entry, change the chainage ranges. So if you only wanted to have this applied over a certain chainage range and then have a different slope in a different area, or manually take control of the design within a certain area, you can do that. But surface extend has been applied for the entirety of this string, and then we have 2 others which have also been applied to this edge here, giving us, in fact, let's have a quick look at that, shall we? Let's go and have a look using toggle display. I will turn on the mesh for the right side. You can see how that's been projected out, giving us that nice, I think this is a positive 2, so it's the opposite fall, but it's making sure that we get that nice plane to drape onto. I'm going to use the grips here to turn this off. Let's now have a look at beginning to build this model using these profile strings now that they've been created and we've reviewed how the design has been set up. So to start with, you can either click on Model Builder from the ribbon, or you can right click on Models and go Model Builder. In here we're going to go and click on Create New Model, and we're simply going to call this model. This one is sort of a temporary model. We're not going to be using it, but it's just to show you what happens when we do not link to Totalmodel. So really the best way of showing you this is simply just to leave that unchecked and click on Create New Model. Now when you're using Model Builder, what you'll notice is that a transparency is applied to all of the content in the drawing, meaning that when you go and turn content on and off, such as this, it's highlighted and you can clearly see what's going on. All that's happening is, if I open up Layer Manager here, Layer Manager has a transparency setting coming from the active settings, applying a transparency of 74 to all of the content in the drawing. If you close the drawing down whilst this form is open, there's no issue with that, but what won't happen is the restoration of that layer transparency back to 0. So you'll need to ensure that you go back here and set your transparency up as you need it. I have seen examples of where users were not aware that that was happening and thought that it was something to do with Model Builder, and it simply isn't. We're just simply setting a layer transparency in Layer Manager for you. Now, what's happening with this version when we're not linking to Totalmodel is the software just goes ahead and says, well, what strings would you like to join together? So let's have a look at what happens when we grab the resheet road, which is this road sort of going west to east, and maybe have a look at the curbs as well. and we'll also maybe just grab the road. Now, when we create Totalmodel, connect two roads together and put curb returns in, the software does a lot of trimming for us and cleans it all up. That's basically what Totalmodel is all about. It goes ahead, it connects all of the road strings and network strings together and does all of this trimming. It's, in a way, it's sort of creating its own model builder model. When you use create a model that is not linked to Automodel, you actually get all of the raw strings in their raw state prior to any trimming. Now you may ask, well, why would I ever want that? Well, there are scenarios, and I've had this one recently, where, for example, a user has wanted just the line work of just one road. For example, let's just say this one, prior to curbs and another road being added in. So if they wanted the polylines of just this road only, they can use Model Builder to do that. If we uncheck the curbs, what you're getting here is a model of just that road, minus any trimming. So if I click Build, we'll get the software. The software actually goes ahead and actually creates, in fact, you can just see them there in the background, some contours. If we toggle on the triangles, I've now got a single model which is connected back to Total, so if Total for whatever reason changes, this will also update, of just this single road. If I then close down the Model Builder interface by clicking on the top right hand corner and clicking Save, yes, toggle display, by the way, automatically pops up like this each time that you close down Model Builder, but you can see I've now got just this single road being modeled. Now the great thing is, if you want to run CAD output of just that road, this is where we have a brief discussion about Linework. Linework for your models is controlled in toggle display only, and in there we can turn on and off the fast draw, which is our special line work which Civil Site Design creates, which is sort of, if you hovered over it, it would say it was a block. We can turn off Totalmodel, and just, in fact, what we'll also do is turn off the mesh and the contours just for clarity. And all I've got is Civil Site Design displaying for me just that one road, just that one single model, so I could now run CAD output if I wanted to. So there are benefits to having just using the model not linked to Totalmodel. Okay, but invariably, if you are designing and you have a road string anywhere in your design and a profile, and a network strings, then yes, you will want to link it. Probably want to link it to Totalmodel. So let's have a look at how this looks. We'll go to Models, Model, right click on Models, Model Builder. That model we just created, if we want to do anything with it, we right click, you can edit, delete, copy, access a number of functions. You can also double click, and double clicking takes us into the form. Now, I'm actually going to that was just an example of how you can get into Model Builder. I actually don't want to go back in there. I actually want to delete that model. So I'm going to go Model Builder, right click, delete model. Yes, I want to delete it. Now you may need to do a regen just to clear up the line work, and if it doesn't go, simply all you need to do is go rebuild models, and rebuild models will just polish that, and that's just sitting there. This button will also rebuild your models in Toolspace if you need it to. So Toolspace is all cleaned up, that model's now gone. Let's now have a look at running that again. Model Builder, create new model. Yes, we're going to call it, so this is going to be roads with parking. Is it linked to an automatic model? Do we want all that nice trimming to occur? Yes, we do. We'll talk about boundary retraction later, because that's a great little function to get rid of excess triangulation, but we'll put that in context with cleaning the model up. Create new model. The difference when you start the model is that automatically we turn on the display of any road and network strings. So you don't have to go about turning those on and off. What we want to do is now add in the additional elements. And really, this is the first part of what Model Builder is about. It's turning on strings, adding them to the model, and simply clicking Build. So this is really all that we're doing, just simply building a model, including these extra strings. Obviously, there's going to be some issues with this, and really just to sort of flesh this out, let's have a look at how this may look in Model Viewer. We're going to try and access Model Viewer as much as possible, because it can just sit there in the background, running, and all we have to do is very simply just get it to refresh. As long as it's showing the model that we've currently got on screen, all we do is hit Build and refresh. So we're going to go Toggle Display in Model Builder, Model Viewer even, and then click on BM Roads with Parking. So software's done exactly what we've asked of it. It's added the parking bays in, but unfortunately the road curb is basically being projected all the way through, and we need to remove it in all these on each of the parking bays. So how do we do this? Well, we'll minimize Model Viewer, And now have a look at the next part of what Model Builder is all about, which is trimming. If we head to the edit panel, edit button, sorry, we're going to edit new road. So we're actually going to be removing the top two codes of the curb from the left side and the right side on new road. When you first open up the edit panel, what will happen is you'll be given a couple of, in fact you can have many entries. If you've got a road string with multiple intersections and curb turns, etc., you can have a whole ton of entries in here that begin or end, sorry, with TM. TM stands for total model. And to show you what these entries actually look like, if I'm just going to select, if I just left click on one, you'll see a couple of lines. Okay. Think of these, if you've used the trim command in CAD, which I'm sure you've all done, think of these as 2 points, the start and the end of a trim. And all that's happening is that the software is taking these 2 points and trimming out a selection of codes which we've told it to remove, which in this case, when Totalmodel creates the curb returns, it removes the curb, leaving the EB code all the way through. Same goes with this entry. Okay, I can't edit these entries because I've told the software to be linked to Totalmodel. Okay, I have effectively XREF'd it in, which means that I can't edit, sorry, the Totalmodel entries. But that's fine, I don't need to edit those entries. What I want to do is add my own. So let's have a look at the left side of the road here first of all. We've got a couple of ways we can remove the codes throughout this part. Now I'm going to use edit trim by group first, certainly the simpler of the two. It's not quite as flexible as edit trim by selection, but we'll have a look at that in a minute. And what we can do is we can choose one of the options within here which suits our requirements. Now, as you can see down here, and in fact, if I left click on this option, have a look at the center line as I do this, and then flick between. So the first option down here removes absolutely everything in the cross section. You may want that. Okay, you may want it to model from one parking bay to the other. You may want to keep the center line in, model from that edge to the center line to the other parking bay. There are other options in here which you can see where it will keep the left edge, keep the right edge. In this case it keeps both the edges of bitumen. You may be thinking, well, that's perfect, but it actually isn't, and the reason why is because the chainage range at the top here would be different for the left side to the right. Okay, so we need to apply something different to the right to the left. So this option is what we'll use for the left hand side, and then we'll create another entry which removes it on the right because the chainage range. So tempting as it is, we might click on the picker tool here, and then you kind of go in and you're using your snaps and you pick away and you say, well, it needs to be there, and then you go and use your snap again and you say, well, actually it needs to finish here, and I'm just clicking on the end of the alignment there. But what you notice is that for some reason the trimming only seems to occur at sort of different positions to where you've suggested. Trimming can only occur where you have a sample line, and these are the sample lines that are generated by the software when you create the profile string, and we briefly explored that on the parking bay where we had 1 meter and 0.5 for the arcs. Well, for this road I've got sort of 5 meter spacings, which is why the software is jumping to the closest spacing or closest sample line that's available. So what we need is sample lines at the particular point where we want to cut, and it's very easy to do. All you do is use this button to add them in. So we click the little add button, add single chainage, and you go ahead and pick that first point. What you don't do at this point is then go and add another one and go and pick the end, because the last completed cell is applied to whichever one of these two cells you're actually editing. So if I go and pick the end here, the end chainage value will end up getting applied to this one because this is what I picked first. So as you do this, you pick your chainage, immediately click OK. That is then assigned to that cell. Then you go and pick the other end. Add single chainage, snap, then click OK, and then that is assigned. Okay. So what we've ended up doing is just very quickly, and we'll just click OK here to complete that, trim the road design exactly where the parking bay TP begins and where it ends, meaning that we've now got a very clean and model. And just to take this one step further, let's click build. And once we've clicked build, all we need to do is just to quickly pop down and fire up model viewer, and if we hit refresh, it's just simply validating. I can guarantee you this is far easier to see what's going on seeing this in model viewer than it is trying to interpret mesh and contours, which I know many people do, but just for getting a sense of how everything's connected nice and cleanly, this is a really good environment to know that everything is working as it should be. So now we've done that, let's just, in fact, we'll close down Model Viewer, save me keep going to my Windows taskbar. We're then going to apply the same process slightly differently to the other side. So to do this, we're going to go Edit Trim by Selection. Now, Edit Trim by Selection, as you can see, actually allows me to go and pick the codes I don't want. Now, before we pick the codes, let's get the chainages sorted out of the way. Now, I don't have sample lines in the positions that I want at the moment, so I know immediately I'm going to go ahead and use the little picker tool, add single chainage, click on the end, and then OK. Then use the picker tool for the end, add single chainage, pick on the end, click OK, and I know that the really all that's left to do is now remove the codes. Now the great thing is that with this one I can actually remove the codes by picking them from the list. So the right back of curve needs to go, exclude, and you can see it's getting removed as we do that, and the right top of curve needs to go, exclude. Now just a quick comment, there is no batter code being applied to any of the strings in this project, but you can the batter code will appear in this list and can be removed and managed in exactly the same way as any other code that you have on your string. Now you may be wondering why there's an include. Why would I want to include something if it's already being displayed? Well, a good example of that can be that an include can override an exclude. So let's just say you did want to show your curb codes through your intersection here for whatever reason. It could be part of a different stage. You maybe have to have that completed. Well, what you can do is create an entry which says include the top of curb code and back of curb code through that particular chainage range, which is why you have the option of include and exclude in that particular list. So basically it does an override of something that's already excluded, which can be helpful. So that entry's finished. We'll click OK. So there are two entries. Now if we want to make edits to those, you simply right click, edit, and that takes you back into the form. And you notice that with the Totalmodel entries that you actually get a message saying you can't edit them, you have to override them, which is kind of what I explained earlier about including codes. Let's now finish off with the last parking bay 3. So we're going to use basically either the picker tool or the list tool, and very simply we'll use trim by group. That's nice and clean, and we'll go and remove the left side only between station range, chainage range of our choice by clicking OK, single chainage, clicking OK, clicking OK, and then simply just making sure that that's built by clicking build. And then really we're just going to use Model Viewer to validate what we've done by having a quick look. It will rebuild and refresh itself as it opens anyway, which is great. And I can see I've got that nice clean tie-in happening to my parking bay. Obviously the elevations are being totally managed outside of Model Builder, which means that I don't have to be concerned about how things are tying in from an elevation perspective. We're going to close down Model Viewer. Once you're happy with the edits that you've been making, really you've kind of seen the extent of what Model Builder is all about. It's very simple. You're simply connecting strings together, cutting the line work or the codes out that are basically not appropriate or you don't need, and then simply building. Now there are some scenarios where building will could effectively encourage zigzagging or sawtoothing to occur, and there can be reasons as to why this is happening, and normally it's to do with conflicting codes. And I'm going to show you two examples. One which is just it's more of less of a visual thing and more of a pointing thing just to talk about, and then we'll show you a visual example. We have a profile string called, here we go, resheet wide and left. Now this is a profile string with elevations being assigned to it, just simply using the reference point feature. Now it's kind of inconsequential to what we're just about to talk about, but essentially that is a string with elevations. The LEB code of our resheet road on our template is being told through a design variation to use those elevations. Okay, so it's using the elevations from that profile string. What I don't need to do is add that profile string, which is resheet wide and left, into my model. At the end of the day, the EB code is using those elevations. I don't need to add the profile that it's using into the model as well. What invariably happens is that you end up with the software trying to read two codes from two strings at the same time in the same place. So over this particular spot here, we've got an LEB code. We've also got the sent line code of a profile string. So if you probably won't see anything happen, but if I add that in and build, and those two ever get slightly different elevations, the software is going to try and read both of the elevations from both the Linework and the string at the same time, meaning that you can end up with a model that's not behaving as expected. So it's important that if you're using strings to control elevations, you don't add them into the model, and you'll soon see that when that happens. Another good example of this is when you add in islands or features that cross over another string. So let's have a look at what's going on with this island. I'll quickly just show you this island has been drawn with an alignment, and then we've created a draped profile. The great thing about draped profiles is that you can simply set them up, reference a surface, apply a template, apply sampling which is relative to the string, or different components of the string rather than one all the way through. But when you update drape profile strings, they'll actually resample, meaning you can actually just simply move them around and then re-reference the surface they're meant to be draped onto. So they do a couple of things in one hit, which makes them great for, as I said, just simply moving around. If we click on cancel here, what we're doing is add the island into the model, and we're going to click build. And I'm going to open up Model Viewer to show you the result of what has just happened there. We saw this on one of the slides at the start of the presentation. We've actually got a conflict between the center line of the road and the island trying to be modeled. Now, there is an additional issue here which will only occur where you have cul-de-sacs and curb returns. You'll notice that we have some sort of triangulation or mesh happening within the curb return, and this is actually in the background creating a number of different strings connected off to the RDUM or LDUM code on your network string, or in this case the curb return, and that will conflict, as you'll see in a second, that will conflict with the model, or this particular string. So we've got two things to resolve here. First of all, we need to remove the center line of the road so that it's not ploughing straight through our island, and then we need to remove the RDUM and LDUM code, or depending on where you are, we need to remove those codes from the curbs. So let's just close this down. And the very typical one, I would say, is really the first one, is to remove the centerline code, because if you're not at an intersection such as this, then for example, you're here somewhere, the network string part of this is kind of inconsequential. It's more to do with what's happening with the centerline, which is what we're going to manage now. So we're going to click on Edit, and we're going to make sure, yes, we're on Resheet Road, and we're going to go Edit Trim by Selection. This you can only use Edit Trim by Selection to remove the centerline of the road. Don't think that you can use this one, because you're not only removing the centerline of the road, you're actually removing everything from the road design in this particular spot, which we do not want. Okay, we only want to remove one code. So we're going to go Edit Trim by Selection. We're going to exclude the centerline. That'll disappear from the screen. But what we also want to do is to remove it through two sort of random locations either side. And this is where, because we don't have samples, as we can see there's one there, we need to add them in manually. We need to click the Add tool, single chainage, and the great thing is you don't need to snap. Okay, you can snap just before, because the software is going to triangulate and model these strings together. You don't need to snap exactly on top, just a little bit before. As you can see there, that's perfect. Don't forget, you can also adjust these numbers if you want to. Click OK, pick the picker tool, add single chainage. These inserted extra sections are actually getting added to your main string as well, so you can actually go into the main insert sections form and edit them later if you want. Click OK, and what we'll now do is click OK and click Build, but it's not going to be quite right. And we'll open up Model Viewer and have a quick look at what's happened. It's nearly there, but not quite. The process of removing the centerline, on the face of it, doesn't look like it's worked. The reason why is because whenever you create a network string, the LDUM, depending on which side of the road you're driving on, the LDUM or RDUM code is being draped onto the edge of the side of the main road and the crown of the main road. And that's why you can actually still see some cyan line work still being drawn in the background. All that is is the DUM codes. So let's just close Model Viewer. To remove the DUM code, all you need to do is to go and pick the curve return that you're editing, which in this case it could be curve north. Click OK. Edit trim by selection, and just remove it, exclude it, and you can see it gets removed. You can still see there's some line work there, and that's because that's coming off the other curve. So we'll go and use the picker tool, edit trim by selection, exclude, and click OK. Click build. Really just opening up Model Viewer just to validate what's happened, and just make sure that it's working as we have intended. As you can see there, we've got that nice clean modeling now happening. The center line is still there, just happens to be cut as it's going straight through that island. Now, let me just show you an example of what happens when you're not crossing over the center line and you are just simply in one of these two zones here. So, and this actually is a nice way of showing you what happens with draped strings. What we'll do is we'll just simply move. In fact, we'll just go to we'll just save this first of all. We'll simply move the alignment that is being used to position this string. Then all we need to do, and I'm just wondering if it's in tool space here. Yes, it is. Update draped strings. So there you go. So either using the pull down here, update draped, or you can right click on profile strings, update draped. Now, nothing will happen in this model because this model it doesn't realize that the entire string has moved. So what I need to do is simply you just do a regen. There we go. Now that centerline cut is completely unnecessary now. All right, so we don't need it there. So what we could do is go back to resheet and basically reinstate that entry. Let's go back to resheet road. We'll get rid of this entry here and delete it. So I do want the centerline to be added back in. So that's fine. That's all gone back in. Let's have a quick look at the curve return here. What I want to do is just to show you what would have happened if we hadn't removed the DUM code. So I'm going to right click and delete that entry. Then simply just click build, get Model Viewer fired up just so we can see what's going on, and then have a look at the island. Because what we should see is that yes, we're not over not crossing over another string, but we've got the sawtoothing happening, and that's just simply due to the mesh that's being created with that DUM code. So all you need to do is go edit trim by selection, remove the DUM code, click OK, and then build. Then all you need to do is hit refresh, and that fixes that up. So hopefully that's sort of giving you a good idea as to what can happen with strings when they are overlapping, and certainly that does happen quite frequently. And as I said, the only reason you get the sawtoothing happening is because something is overlapping. Let's close down Model Viewer. We're now going to have a quick look at what's happening with the line work in this model. Now, the line work of a built model probably, for many of you, will look like it's drawn in a different color to the line work that you normally use with your strings. And the reason why is because it's actually controlled separately. So traditionally, your fast draw line work is controlled under something called assign layers. Okay. Now, I think on the tool space you can also find assign layers. Well, you'd have to go CAD output and then find assign layers through here. So it takes you to exactly the same form, but it's worth showing you how you can get to it through tool space. So the fast draw line work, which is everything that just Civil Site Design draws for you off the bat, is drawn using these particular colors, okay, and on these particular layers. Line work, which as we've established is not polylines, you can't necessarily plot it or XREF it, so we encourage users to use the CAD output, and at which point it will output all of the polylines of your fast draw model to actual layers and chosen colors that you can set through here. Now the fast draw for a model builder model is actually slightly different and controlled using this button here. So if you click on this button, there are two options, default and hide display. Let's click default. Now in your common folder, this controls the color of the line work for model builder models, and it just happens to be different. So my centerline is drawn in yellow when I'm using a model builder model, but when I'm using assign layers for just straightforward roads and curbs, etc., it's always being drawn in green. So if you're wondering why it looks different, it's just simply being controlled in here and really doesn't affect anything. It's just simply a different color to basically show you that you're drawing with it, or you're looking at a model builder model as opposed to a regular model, which can be helpful. You'll notice you can save this as a sort of a different file, which means that when you load it in, or when you start Model Builder by clicking the button above, you can choose your particular color file that you want to use. The hide button shows you, or the hide line work button shows you all of the line work which has been trimmed. So as I'm doing that, you can see all of the line work which has been trimmed for my model. The color file for that is called hide display. Very simple, everything's gray. Okay, don't suggest you would need to change that unless you really feel you need to. So the button above says, well look, if I'm going to be showing a color file, which one would I like to use? Default. If I'm going to be showing a hide, that should really say hide display, or alternate, what should I show? Use hide display. So that's all that button does. Okay. Let's close down Model Builder, clicking on the top right hand corner here, and click Save. Just say yes, we want to save it. Again, we're always prompted with the toggle display form, so we can now go and turn on and off line work that we do or do not want to see. Okay, let's click OK. Now, if at any point you need to update your model, or you find that you've made a design change in maybe your profile string here, horizontally or even vertically, you can always rebuild the model in tool space by clicking on this button here. You can also come to your model and click on right click and go rebuild model, which will update that particular model for you. If you're finding that from a performance perspective that it's maybe a little bit slow, I'd recommend you head to toggle display, models and line work, and uncheck dynamic for the maybe the built model. Okay, meaning that it'll only update when you tell it to by clicking on rebuild, which can be effectively a performance saver for you. So we're going to have a look at how we can clean this model up. So what I'm going to do is left click on one of the contours and hover and go show triangles. And you can see we've got a lot of excess triangulation, and that's absolutely fine. All the software is doing is simply joining the strings together. It doesn't know the extents of our surface. So this is where we can head back to Model Builder and apply something called boundary retraction. Now, boundary retraction works slightly differently to maximum triangle length. It actually looks for triangle lengths on the extents of your model and works inwards, rather than you getting triangles disappearing from the interior of your model. So if we click on this and type in maybe a value of 12 and click rebuild, we get the vast majority removed. Now let's take this number down to maybe say 9, rebuild. Pretty much got rid of most of them. We'll take this down. The sampling of our road is around 5, so I'm going to maybe suggest we go for 6 and rebuild. And yeah, we've got rid of the vast majority, but importantly, we haven't lost these triangles here, which are actually over 6 meters, which is great, which means that we've basically got rid of the worst of the modeling. Once you've done that, you may decide, well, look, I need to clean this up further. And one of the benefits of cleaning it up is when you come to do your cross-section plotting, the software is going to be picking up potentially the edges or the extents of some of these triangles. So how do we clean it up? Well, very simply, we access Surface Manager. So I'm going to right click on CSD Surfaces, Surface Manager, find a model. You could have done this, by the way, via the ribbon. I'm trying to use the tool space as much as possible. You can, with a Model Builder model, actually add additional CAD objects to it to continue its build. So if you, for example, had 3D polylines from somebody that's not using, say, for example, Civil 3D or Civil Site Design, whatever it happens to be, you can actually import those 3D polylines as a layer and add them to the build of your built model. You could also apply boundaries, and you can also do editing. Okay, if we hover over the edit, go delete edge, we'll just get rid of some of the excess triangulations. So this is just like drawing a polyline. Left click, and we can keep drawing and press enter to finish. If you don't like that edit, you can simply click to remove it. You can also hit the delete key to remove it. I actually did want that, so we'll click on delete edge, get rid of those triangles, press enter. And if you want to know where these particular entries are, I think in 23.1 we added a little zoom on here so you can actually find the line that you're now editing, because once you've got a big list of these, they can be difficult to find, particularly if you want to make an edit to one of them. Do bear in mind though, as I'm making these edits to this model, if this model ever grew, as in I wanted to add additional strings to sort of the extent of the design further out, for example here, and I add this delete in, that delete is permanent. Even if I add extra strings in, the software is being told to remove any triangulation of the surface. So you need to bear that in mind, that if you're not seeing something and you've got deletes being applied, it's invariably that your deletes are removing those aspects of the model. Now, I'm pretty happy with this. Yes, it needs a little bit more refinement, but I'm pretty happy with how that's been set up. I'm going to just simply close down the Surface Manager form. I'm just really going to show you I'm now going to show you how we can look at getting a subgrade model from this, and this is something that we covered in a webinar a few weeks back, so have a look at our webinar playlist. We're going to create a subgrade model by clicking on Subgrade Model Manager. Create a model. We're going to leave it as submodel and simply just pick roads with parking. We're going to leave everything by default. Okay, we do have boundary retraction in here. In fact, what we might do is, we'll probably just add a little bit of boundary retraction on there, maybe get that down to 10 and click OK. It's the same process which is applied as Model Builder. Now, we're not going to go into the depths of what's happening with the subgrade model, because as I said, that's covered in that other webinar. But one of the benefits of running the Subgrade Model Manager is I can actually see here, and this wasn't actually picked up when we put this together until we sort of opened it up in the Subgrade Model Manager, I actually have a conflict of subgrade between my curbs. Yet on plan, everything looks great. Okay. Everything looks perfectly fine, but the subgrade extensions on these are quite extensive, and as you can see, they clearly overlap. So there's a benefit of opening up just to view your model in the Subgrade Model Manager. Now, what I'm after is a surface. And because Subgrade Model Manager works automatically, it's generated a surface for me, which, yes, I can go in and make edits to and change, but ultimately I want to see this surface in my cross-section plotting. Now, because the surface has been created, I can just close down Subgrade Model Manager. I can come back into that at any point and make changes. You'll see that under Surfaces now, I've got a submodel surface, okay, which I can then turn on and off the contours for. In fact, let's just clean this up a little bit. Let's turn off the triangles for the built model, and the subgrade model I think has also got the contours on, which we don't need to see, so that's cleaned up as well. We're going to show you using those our two surfaces now. We've got a top surface and a subgrade surface, how you can see them without plotting. And we've got a line. Importantly, this is a line, not a polyline, and I'm simply going to drag it across the model here. I'm then going to type in ARD UV7 index road. Now, this is a command which is not found anywhere other than the command line. When you pick the line that you've drawn, the software will automatically display every string that it crosses. So if you're not using Model Builder and you have lots of strings that are sort of overlapping and whatnot, this won't probably be as good as what we've got here. But you can see here I've got my road cross section, I've got my curb. It is picking up, don't forget, it is actually picking up the original string cross section. So this is why this command is not sort of fully fleshed out as an official command in the software. So it's giving me some semblance of what's going on, but it's worth pointing out that it can be of some use to users if you need it to. What you can also do, if we go to display here, you can actually get it to show the levels and the codes just like you would do in a cross-section window. We can also get it to show another surface. So I'm just going to get it to show the subgrade surface here, submodel. In fact, what we might do is also get it to show the built model. Click OK. So this is actually now showing me where my surface would be. This is actually my built model surface, which as you can see, because it's picking that original curve up from the road cross section, isn't quite right. But this command I expect will at some point improve. You can see the subgrade surface in here as well being applied. There's a surface resolve, as it's called, in the Subgrade Model Manager, followed by the remainder of the design. So take this with a pinch of salt. You may find it's useful. The good thing is, though, you can actually just simply move the line around to get a sense of what's maybe happening with your model. We are going to plot cross sections, though. That's the key thing. We're going to plot cross sections along new road here, showing the surface at its extents. So to do this, we're going to go ahead, go cross sections, click near the road here, new road, click sample sections, and at the moment this is using a previous design in here. We're going to just remove it and start from scratch. So I'm going to just delete the submodel that's added in here and delete the built model. So really what we're left with is this sort of blank canvas. What I want to do is to now see the Model Builder model and the subgrade surface. Now, there is normally the subgrade band added in within here, which I've also deleted. Whenever you're going to now add a civil site design model into your design, we recommend you pick surfaces, not built models, because surfaces has had some development over the past year or so, past couple of years, to ensure that you can really just pick up the codes of your models, not all the triangulation. So in here, all I'm going to do is go and pick my built model. Do I want to draw a band? Yes, I do. Do I want to draw a section line, or surface line effectively? Yes, and it's called XPlot Design. I'm going to click OK. You can see it's done a pretty good job there. A lot of excess triangulation, and that is the triangulation that is occurring between the backs of the parking bays. Okay, so that can actually be cleaned up by me. I can go in and clean this up further. If I go BM roads with parking, offset controls, and just put in a grade break of 100 and click OK. And what that'll do is that'll actually go in and clean up a lot more of the model if I need it to, if I hadn't removed the excess triangulation. So that's given me a pretty good clean cross-section view, okay, that I'm after. What I'd like to do is now add the subgrade. So I'm going to go in and add a surface again. Now you could right click and go copy at this point. If you want, you can go copy, or you can just go and pick surfaces, which is what I'm going to do. We're then going to go ahead and pick our surface submodel. Now I don't need a band for this, okay, I just wanted to draw a line. I'm going to put it on a layer called XPlot Subgrade, and then we're just going to see the result. A lot of extra triangulation, going in on this, which has now been picked up and added to the bands. Now what I want is for this surface to be drawn but not added to the bands. So I double click on submodel. You could, if you wanted to, use the grade break filtering down underneath like I did earlier, but really what we're saying is we don't want any of these grade breaks. We're not interested in the grade breaks, it's just a visual, we just want the line. So all we do is we remove the band offsets from the master group so that it's not drawn, and click OK. And therefore we've just given the line work. Obviously the submodel would need a bit of tidying up as well with regards to deleting triangles, boundaries, etc. But it is drawing exactly what we have got within the for the purposes of the surface. Just a quick word about offset controls. If you wanted to control the extent of the cross sections to not just be 10 meters, which is what they are either side of 0, that is controlled simply just using widths and text. Okay, so you can say symmetrical, yes, 10 meters left and right. If you wanted to take this one step further, what you could do is, if we just go to variable section widths, you can actually use, for the line work and the text, you could use the alignment. So what I could say is on the left side, only use the parking bay, parking 1, and what this will do is it'll only extend the cross sections as far as that particular alignment and no further. We click OK. Meaning that yes, we get this variable width, and because the curb is actually behind that alignment, we're not actually seeing it. But you can use alignments, Civil 3D or Civil Site Design, to control the width and the extent of your cross sections, even to just have them only display the left hand side. So for example, if you want all of the bands to display but none of the line work at the top, for example you're doing a half road, you could say, well look, yes, draw the line work, okay, but restrict it by the alignment, which may be the center line. I don't want to show the left hand side, but do show me all of the text, making sure that all of the text is shown on the left hand side, even if it's not actually there visually. So you can use this to control the extent of your cross sections. We're going to click close, and then lastly we're going to just simply plot using this Civil 3D alignment, which has a profile string on it, and all we're going to do is go up to the which in fact I'll just show you very quickly. This is essentially a dummy profile string. We're just using it for the purposes of plotting. The profile that's actually on here, the vertical design that's on here, is actually irrelevant. We're not needing it. What we want to do is to show the natural surface, but as it crosses the natural surface, show our model instead. So we can go long section plotting. I should stress we can also go plotting using these buttons down here, but I'm going to go long section plot, click plotting alignment, which has that profile string. And what we need to do is, if we use the little zoom tool here, at the moment it's not showing us anything for the design surface. We'll go set up row data, and this is the entry. So at the moment we've got the existing surface, which is just very simple. show us the existing surface, or the sampled surface, as it follows along our string. What we want to do is say, well, actually, in addition to that, also show me the built model surface. So we click the little pencil icon, leave everything as it is. Instead of saying sample surface, we're actually going to go ahead and pick BM roads with parking, then click OK, click apply and exit, update display, and that will now pick up. Essentially, it views that as a sample surface, now picking up our road design and our road and parking built model as it crosses over, which we can then plot to layout. That's pretty much where we wanted to leave it today, but hopefully by watching this you've gained a better understanding as to how Model Builder operates. Hopefully you'll be able to go ahead now and begin to experiment with what you're able to do with it, but certainly for many projects, once you begin to learn how to extend outside of sometimes the constraints of simple, just basic cross-section design, Model Builder has a real, gives your users a real opportunity to begin building some complex but very simply put together models.